Okay, let's get started. So hello everyone, and welcome to this ISCARSAH webinar on the fire protection of heritage structures. My name is Tim Michiels, and I am a structural engineer at Old Structures Engineering in New York and a professor at Columbia University. Moderating this webinar with me is Dr. Nicoletta Bianchini, who is an Italian architect and engineer currently based at Atkins Realis in the UK. Today's webinar is brought to you by ISCARSAH, or the International Scientific Committee on the Analysis and Restoration of Structures of Architectural Heritage. While more people join, I will briefly introduce our scientific committee. We are an international group of engineers, architects, scientists, and educators dedicated to the restoration and care of built heritage. We mostly focus on the structural and technical aspects of conservation of architectural heritage. We have a diverse board with, at the helm, our president, Paolo Lorenzo, and our secretary general, Tom Morrison. The goals of ISCARSAH are, amongst others, to disseminate knowledge, promote international cooperation, and organize international training programs. Another goal is to collaborate with other scientific committees, and we are happy to welcome speakers and members from a wide variety of ICOMOS committees today. In the past, ISCARSAH has published principles for the analysis, conservation, and structural restoration of architectural heritage, and we are currently finalizing the monumental task of creating updated guidelines for the analysis and restoration of heritage structures. We publish newsletters and a bulletin and organize 2 webinars each year, all of which can be found on our website and YouTube channel. We also organize workshops. The last one was in Iran. The last ones were in Iran, Korea, and Japan. The next workshop and general meeting will be held in Romania in September. Thank you, Radu Kazimir, and all of ISCARSAH Romania for organizing. You can still sign up and join us in Romania in September. Finally, I want to acknowledge that this webinar was made possible by several people, especially Steve Kelly, Tom Morrison, and Paolo Lorenzo. You can reach us at iscarsah@gmail.com, follow us on Facebook, or find our website. Okay, that brings us to today's webinar on fire protection of heritage structures. The worldwide attention to the catastrophic burning of the roof of the Cathedral of Notre Dame in Paris, which happened 5 years ago as of yesterday, put perhaps the largest spotlight in years on the vulnerability of some of our heritage buildings to fire. In the meantime, we have unfortunately been reminded all too often that fire can strike anytime and anywhere. The recent traumatic burnings of the Brazilian National Museum, Shuri Castle in Japan, or today's blaze in Copenhagen here illustrate that. As heritage professionals, dealing with fire is not a new task. Adaptation to fire has shaped our building practices for centuries, as structures have been burning and rising from ashes for ages. As caretakers of historic buildings, we are not only tasked with the aftermath and restoration or reconstruction, but also have a duty to protect and plan ahead for the next fire. At ISCARSAH, we believe that knowledge transfer and education is one of the key elements to help mitigate fire risk. Therefore, we have assembled 4 experts today that have dedicated their careers in part or in whole to assessing and mitigating fire risk. We bring to you perspectives from New York, Iran, Switzerland, and London on fire risk in Mongolia, Isfahan, Bhutan, and France. On behalf of myself and my co-organizers and the entire ISCARSAH community, I would like to thank these speakers for their dedication and for sharing their experience. With that, our first speaker today, and Jose, please start sharing your screen. Our first speaker today is Jose Torrero Cullen. He is professor of civil engineering. Sorry, 1 second. Of civil engineering and head of the Department of Civil, Environmental, and Geomatic Engineering at University College London. He works in the field of fire safety, where he specializes in complex processes and environments. Prof. Torrero Cullen has participated in numerous fundamental research studies that range from how fire affects historic buildings to modern architectures and even spacecrafts. He has developed novel technologies that use smoldering combustion for the purpose of resource recovery that are being used globally, and he has received multiple multiple awards. He's a chartered engineer in the UK, a fellow of the Royal Academy of Engineering, the Royal Society of Edinburgh, the Australian Academy of Technology and Engineering, the Society of Fire Protection Engineers in the US, the Institution of Fire Engineers in the UK, the Institution of Civil Engineers in the UK, and of the Combustion Institute. Prof. Terrero Cullen will speak about the fire at Notre Dame Cathedral. Please take it away.
Thank you very much for the kind introduction. And yes, I'm going to talk briefly about the fire at the Notre Dame Cathedral in Paris. And, as you mentioned, today we have this fire in Copenhagen, and Copenhagen happens, that particular building of the stock exchange happens to have one of the most extraordinary steeples in Europe that has been lost. And reminds us with great pain of the collapse of the steeple of Notre Dame, which actually was unveiled not that long ago, its reconstruction. So it is a painful reminder, as you said, that fire is always present, and we always have to be prepared ahead of time. So this presentation doesn't intend to be a detailed analysis of the fire and its consequences. It's just going to highlight a few aspects that reminds us of how prepared do we need to be. So, the first point that I wanted to make is the nature of the structure of Notre Dame Cathedral and the nature of the hazard itself. As you can see, is a stone structure, traditional Gothic building, and we see at the top a stone vault, and on top of the stone vault, a timber roof. Now, in a similar way, on the image on the right, you will see the timber structure inside the belfries and the timber steeple that is on top. Now, these particular systems obviously pose unique hazards that need to be addressed, but for that purpose, we put and implement different forms of fire safety or fire protection to try to make sure that at the millimeter of the church. So if we look a little bit more in detail at the hazard, we realize that this is a very unique system that poses a particular challenge. Now, the particular challenge is in the structure of the roof. Is a timber lattice that has two layers, and with a gap in the middle, and that is supported by a timber structure that has beams and of much bigger dimension, both transversal and longitudinally. The longitudinal ones are smaller, and every once in so often you get a very significant structure with very significant beams, and those beams you can see in the images to the top left. You can see on the bottom left a photograph of what is nicknamed the forest, and basically it's the structure of the roof. The structure of the roof. Now, this type of timber structure has the potential of burning quite easily. Is very dry timber. It has very, very small elements. They're all aligned very close to each other, so there's a very significant amount of radiative heat transfer. So the hazard is a very, very significant and recognized hazard. It's something that we know actually is the case, that exists, and that therefore we should be protecting for. For that purpose, you can see in the two right images the lead shingles or the lead cover that was used as protection that had been taken out for repair. And this is, I guess, the key question. So basically, we have a very well-known hazard that we know is an extraordinary hazard, and we have a mechanism of protection for it, and that mechanism of protection has been taken out. And it has been taken out rightfully for the purpose of developing repair works. So now the question really is, what is the kind of precautions that should be taken? What is the kind of training and competence of those contractors that are working on this, and how we should guarantee that an event of this nature should never happen? Because in principle, that is the key question to be addressed. This event should have never happened. So why did it happen on the first place? Now, the origin of the fire remains a mystery, and all the fire investigations that have happened so far have not revealed exactly what happened. Nevertheless, it is logical to infer that there is a relationship between the work that was being done and the event. So here you have a series of key events, and important to note is that if you look at the 2 points on the left, top left, that this is a very sophisticated smoke detector, but that very sophisticated smoke detector required visual confirmation. Now, this is a bit of a problem because, in essence, what you get is the need, before you call the fire service, to be able to bring somebody up, and that somebody has to verify that there is a fire. Only then you call the fire brigade and you start the process of addressing the event. And the fire was detected at 6:18, but it was not confirmed until about half an hour later. So the first engine does not arrive until 7:25, and basically to start with the appropriate external attack. In the meantime, the firefighters that arrived about 30 minutes into the event. Now, in timescales of a fire, a 30-minute delay is an extraordinary delay, it's an absolute lifetime. So creating a protocol that resulted in a delay of more than 30 minutes, that almost brought the appropriate appliances an hour later into the fire, is something that is completely unacceptable. So furthermore, there are issues with the incapability of the systems to provide water to the roof. The water was reaching only the walls of the building. Furthermore, there was a standpipe that was not functional, for which the fire service had to improvise and extinguish the fire in the North Belfry, carrying spools of hoses up a terrace and draping them over the facade to receive water supply. So in essence, you can see this is not one intervention in which things are working the way they are supposed to work. So one key aspect of this event is the fire in the belfry. Now, the fire in the belfry was very, very important because it's a very strong timber structure that holds, as you can see from the table on the left, holds massive bells that are, the biggest one, Gabriel, is about 4 tons, 4,000 kilograms. Now, we did an analysis of what would have been the potential consequences if one of those bells actually collapsed. And as you can see from the diagrams, the models on the top, on the bottom left, you can see that you would have had a complete collapse of the interior that eventually would have potentially carried over the belfry and potentially a significant part of the facade. Now, in the photograph, you can see how the timber has charred, and in the top beam that holds the bell, you can see that there's a failure of the beam. Fortunately, the bell was stopped by the bottom beam, and the firefighters actually managed to stop the fire in that particular belfry. So if the North Belfry would have continued to burn, the consequences would have been completely different to what we saw. So this image is very revealing of the lack of preparedness. You know, when you see the firefighters trying to throw water to the cathedral, and you can see how far the water jet reaches, and it clearly does not address the fire itself. So if you look at the timeline, you can see that for a long period of time until almost 8 p.m., the water that was being supplied was not reaching the roof, and the fire was spreading dramatically along the nave towards the choir and in both directions of the transept. So in yellow, you can see the direction of spread in that period of time when effectively no water was getting to the fire. Now, if you look a little bit later, then you can see that that the fire has now spread, you know, all the way to the end of the roof. And you will see how you have this very, very large fire that is basically the thinner elements of timber that are burning close to the roof. You can see behind the thicker elements of timber And then further behind, you can see the bigger beams. And then behind, you can see the steeple. So eventually the steeple will collapse, perforating the vaults and landing an enormous amount of burning debris into the interior of the church. Now you can see now at this point in time, it's about half an hour later, the fire has already spread all over the roof. And finally, it's only at this point where the firefighters can actually reach with water elements of the fire with pump number 2. Now, pump number 3 is being moved away towards the north belfry to try to fight the fire on the belfry, and that pump who was trying to stop the fire in the roof considered that fire was already gone and start taking control of the north belfry, which technically speaking was a very good decision by the firefighters to try to stop that fire. So, but nevertheless, at that point in time, as you can see, there is basically no roof left. The steeple had collapsed at about 7:50, and basically the roof was already gone at that point. One aspect that was advertised very strongly by the media was the use of Colossus, which was an automated robot that went into the church and tried to fight the fire. Now you can see from the image on the left that the jet is being pointed towards a fire that is above, and the water is really not getting to the fire. Now, it was somehow effective in fighting the fire at the ground of the cathedral, but that was a really secondary fire because given the volume of the cathedral, that amount of fuel would have not been that significant. So in essence, while this was very heavily promoted as being an extraordinary success, the limited success of the use of this robot is something that we actually have to consider, when we think of firefighting tactics, for a building of this nature. So as you can see, this is not a prime example of extraordinary performance in response and preparedness. And I think we need to really think very carefully and ask ourselves the question, whether in an event of this nature, it is acceptable to be so unprepared, with dealing with absolutely invaluable patrimony. Notre Dame is one of the symbols of France and of humanity. Its value is unmeasurable. And the risks and the hazards were very, very well known. And it is difficult to understand how a sequence of events of this nature can happen from the onset of the fire all the way to the response, intervention, and so forth, that allowed a situation to build up to a point where we lost complete control, and the fire basically destroyed a very significant part of the patrimony. Thank you very much. I think that's pretty much all I have to say. So I'll mute myself and I'll pass on, back to the moderator.
Thank you, Professor Torero Cullen, for the very interesting presentation. I'm sure later in the Q&A discussion, we will talk about your final questions. And first of all, let me say that it's an honor for me to moderate this webinar today together with Tim, and I thank you, ISCARSAH, for this opportunity. Now let's move on to the second speaker, who is Chris Marion, a fire disaster risk management consultant. His work focuses on the protection of historic structures and natural heritage sites from fires and wildfires. Chris is the founder of Marion Fire and Risk Consulting, a special expert for the National Fire Protection Association, a National Fire Heritage Center director, and a fellow of the Society of Fire Protection Engineers. Today, Marion will present the case study of a Buddhist monastery in Mongolia implementing a risk-informed approach. Thank you, Mr. Marion. The floor is yours.
Thank you very much, Nicoletta. Can you hear me okay and see the screen okay?
Yes, you can go ahead.
Perfect, thank you. Well, I'd like to thank you very much for the kind introduction, and Tim and Steve and all of ISCARSAH and the participants, and also just thank Professor Torero for a very interesting presentation as always, and just again, very much agree with what he's saying, and that there's so much that we do know about fire and making more risk-informed decisions, and that we do have the means and capability to limit these and prevent these types of fires that we've seen here at Notre Dame and again this morning in Copenhagen. So thank you very much for that. What I wanted to speak about this morning was just about a Buddhist monastery in Mongolia and looking at taking a risk-informed approach, kind of a low-tech approach to protecting this for various reasons. So with that, briefly, a little bit of background. This was a Buddhist monastery built in the northern region of Mongolia back in the early 1700s. It housed basically up to a couple of thousand monks practicing and studying here at its peak. It had been abandoned for some time during the mid-1900s and a couple of restoration projects in recent years. It is one of the national treasures of Mongolia and on the list to be a World Heritage Site. I got involved through the U.S. Ambassador's Fund for Cultural Preservation several years ago after some fires at the National Gallery of Art there in Mongolia and some relatively small fires, thankfully, at the monastery, but there was raised concern with regards to that. As you can see, it's in a very, very remote area. I mean, this was about 6 hours outside of Ulaanbaatar, the capital of Mongolia, and the last couple of hours of the trip were actually over kind of dirt roads and through streams and so forth, and there's really no towns, no emergency responders or any assistance like that in anywhere near the near vicinity. It is a large monastery consisting of 28 temples. There's a monk's dorm adjacent to that, not within the overall monastery area. And the main temple within this is here. It's the Chogundugan Temple, and you can get an idea about the size of this main temple and the interior. In terms of developing a risk-informed management plan to help in terms of reducing the potential for fires, just looking at the overall disaster risk management cycle, which some of you have probably seen, where we're trying to address, before and trying to limit fire from happening, and then obviously planning should something happen in the emergency response part, and then having plans in place for resilient recovery. What I wanted to focus on more this morning was just the before portion in terms of developing a risk assessment and risk reduction measures, and also getting into some emergency preparedness. In terms of the process, first starting out is understanding our goals and objectives and what it is that we're trying to do, and should there be a fire, what are the limitations, hopefully in terms of amount of damage. Once we understand what we're trying to do, the next is doing a hazard and risk assessment to understand from a fire side what some of those may be and where our vulnerabilities may be. From there, we then look at, okay, understanding that, what can we do and put in place in terms of prevention and mitigation measures, and then developing and implementing an overall strategy in order to accomplish our objectives. Looking at objectives, a few different things being cognizant of was obviously the safety of occupants and the emergency response team. We're also obviously looking at protecting the historic structure, but as well as the collections and content. We want to maintain the intended functionality, and in part what that means is, we'll get into, is just the burning of candles and butter lamps. So we're not looking to say, well, you can't do that, but it's acknowledging that's part of the functionality of the monastery. How do we do that safely? And then developing an overall risk-informed fire risk management plan that accomplishes a few things, including incorporating the inherent features where we can, embracing local indigenous traditions, knowledge, materials, and resources, minimizing the impact when we do that in terms of limiting impacts on historic fabric, and that the solutions are integrated and work together. The other thing is obviously being aware of resources, particularly financial resources, and having measures that are cost effective and low cost, high impact. And also that these aren't just, kind of day one that they work, but thinking also going forward and some of the different issues that they have, but making sure that these are really sustainable in terms of a long-term effective perspective. In terms of ignition sources, just a quick overview and not getting into a whole bunch of detail, but some of the main ignition sources are the burning of candles and these butter lamps, which are kind of chalice-shaped cups, so to speak, where they put actual butter in and then they burn cotton wicks They leave these in the monasteries until they end up burning out. Prior to arriving, these could be made outside by people coming and camping out outside. They would then bring in these offerings, light them, and there was really no limitations in terms of where they could place these. And there were a few instances where you do see some charring on some of the wood within. Beyond the open flames, we also have a fair amount of issues with regard to the electrical. Winter times there are -30 degrees Fahrenheit, so it's very cold. A lot of the insulation you could see gets fairly brittle and cracking. But even in terms of the connections with regards to the electrical, the equipment that's there, there's a lot of issues where we could have potential ignition from electrical wiring equipment, lighting, and so forth. The other thing is just not just looking at inside, but also external. Again, people do come to visit and stay and camp out on the ground surrounding. So in terms of the grasslands, close by, looking at camping and campfires and cooking that goes on and smoking. And even it's in an area where there is a high activity in terms of lightning. A fair amount of combustible materials that has accumulated over the years that were noted, as you can see here. Some of this debris could probably be removed, and others they may want to obviously keep. And then in terms of overall mitigation systems, it was nothing at the time in terms of fire detection and alarm systems, in terms of automatic suppression systems. Again, you can see here how remote this is, and no emergency responders and no emergency response teams up on site. And nothing at the time had really been done in terms of any planning or training or running of drills. So kind of encapsulating that, what does that mean? In summary, we have a lot of potential ignition sources, which means there's a higher probability of there being ignition. We have a lot of combustible materials, which can lead to fast growth, large and long duration fires. Without having any automatic detection or alarm system, delays in responding and notifying people to be able to try to put the fire out while it's small and manageable. There's no limited suppression system, so the fire will continue to grow if it's not fought in manual suppression. And with the limited awareness and training, it will be very difficult in terms of response and trying to do any kind of manual firefighting. And that these 28 temples within the overall monastery are fairly close, so there's a chance for fire to spread. So what do we do? Looking at two things. One is, can we reduce the probability of ignition and that even happening? And then the second part is, okay, what can we do to try to limit the overall magnitude and size and growth of the fire? So in terms of reducing ignition sources, again, we don't want to be saying you can't have butter lamps and candles and so forth, but what can we do to make this a little less susceptible to fire? One part is just looking at some of these butter lamps, and can we help stabilize these so that they're not able to tip over as readily? One thought was just looking at kind of taking a concept of a wine rack and flipping that over, where these butter lamps could be inserted and they're not as susceptible to flipping over. Others is just putting them within some type of kind of metal container that has sand or water, that if they do again tip over, that they would be in there within that container. And another is just even moving these to an exterior location or putting them within containers to try to limit tipping over. There were also other recommendations, in terms of upgrading the electrical, as well as just developing procedures for people that are coming to visit, lighting butter lamps inside, how they're made outside. These people come in and make their own oftentimes and bring them in. Procedures as well in terms of, camping and campfires, and where these butter lamps may get placed within the temple there. In terms of combustible materials, again, prevention, if we can at least separate ignition sources from combustible material, but also reduce the quantities, whether we can get rid of that, whether we can move some of these out of the main temple, which is really the most susceptible and really the one they're trying to protect the most, but even to relocate these in some of the smaller temples adjacent to this if they need to keep these. But again, whatever can be done to try to reduce combustible materials will definitely help. In terms of mitigation strategy, broadly, globally, we're looking at detecting a fire. Once it has started, we need to notify occupants and emergency responders. They then need to respond, and then suppression activities can begin. As you can imagine, though, we're not able to really do that in this particular location due to a number of things, from where it's located, and especially resources and financial resources in terms of trying to parallel what may be done elsewhere in the world, is looking at having more of a manual detection, notification, response by people there on site. So what this may look like a little bit closer was looking at, having the butter lamps in the main temple area, which is where people really wanted to be, and not have those in the surrounding other 27 temples. And then having some of the younger monks, there's monks there was probably about 40 of them at the ages of probably 5 to 15 that are there studying and practicing. So have them, maybe an hour or two kind of fire watch throughout the main temple area. Yes. Okay. In terms of notification, is just looking at the bell at the main monastery had fallen. So looking at using the conch shell, they were using these to wake people up in the morning to call them into prayer. So they were very, very cognizant and tuned into that. Suppression, Mongolia has some of the best cashmere and wool. So using in terms of wool blankets, in terms of sand and dirt, they had a small portable water storage container, but looking at using this for suppression within the area. And then just looking at creating awareness, capacity, and training. This range from the head of the overall site and walking them through and creating awareness about the issues. We did a lot of training in terms of the younger monks, stop, drop, and roll, feeling your door. How do you try to limit hazards and so forth? And then also just from a broader perspective, I'm working with the local community, the Minister of Education and Culture, the U.S. Ambassador, the Arts Council of Mongolia, and so forth. So with that, we were able to come up with an overall strategy that met the objectives. Again, looking at putting in sprinklers and fire alarm, the main challenge there was, one is cost, the maintenance, the temperature and the freezing, the limited water supplies and so forth. So there were a significant number of challenges with doing that, and then the money that was spent, and then just 6 months, a year, 2 years from now, would that be operational and functioning? This was at least the first approach to try to limit fires and the extent of damage as much as possible. So with that, I'll bring this to a conclusion, and thank you again very much for your time and opportunity to present this.
Thank you, Mr. Marion. The pleasure is ours. And I would like to invite participants to post their questions in the chat. And at the end of the presentations, we will be happy to read them to the speakers and to start a discussion. Now let's move on with the next speaker, who is Mehrdad Ejazi, Professor of Traditional Structures in the Faculty of Civil Engineering at the University of Isfahan in Iran. He is the Chief Advisor to the Iranian Ministry of Cultural Heritage, Handicrafts and Tourism. He is the first scholar who has investigated Persian architecture from a structural engineering point of view. He has been the director of structural restoration works for several national and world heritage sites in Iran. Today, he will present the recent activities for developing the fire risk assessment and management plan for the Nashejan Square, a World Heritage Site in Isfahan. Thank you, Professor Ejazi, for accepting our invitation. Please, the floor is yours.
Thank you very much, Nicola, and thanks, Jose and Chris and all the people who are present here. Actually, I'm going to give you the general plan that we did for Nakhchivan Square, which is somehow similar to what Chris explained. First, I go to introduction, then objectives, and then collection and compilation of fire regulations, and then I will explain briefly about fire risk management of the site. The site is quite huge. It's more than 500 by 100, and there are 4 bazaars around, and three main buildings of Isfahan. It is a World Heritage Site, and it was built about 4 centuries ago. And these are the main 6 parts of the site. As you see here, this is the main mosque, and inside here you see the second mosque, and inside, and here you see a palace, and the palace has a wooden part similar to what Chris showed us, and also inside there are some precious paintings and so on. And also it is the entrance of the main bazaar, which is itself a precious piece of art here. And also around, as you see here, there are some shops, and here you have ignition sources that we had to tackle. The objective was first to collect and compile fire regulations in historical buildings, which are mostly made of masonry and in some parts wood. And then we planned the fire risk management of the site, which included fire risk assessment, documentation, fire risk reduction, plan for passive fire protection, plan for active fire protection, and a plan for intervention of the fire brigade. Actually, UNESCO had asked Iranian Ministry of Cultural Heritage in order to make a disaster risk management plan for it, and one part was fire. And Isfahan municipality and Isfahan Fire Safety Services Department was in charge of that. And we in the University of Isfahan did the project, and also the main user is the Cultural Heritage Organization, and also the people who live or work there. And the project was carried out in more than a year, in 2000 to 2021. The first part of the project was to collect and compile some fire regulation. As you know, there are so many regulations all around the world. Even in Iran, we have a regulation for that, but we had to somehow choose the regulations and comply with the situation that we had. We were able to do that. We made a good search on fire risk assessment method, documentation, fire risk reduction, and so on, which were suitable to the site. And then we went to the fire risk management of the site, and the first part was understanding and identify the site based on fire risk. In order to do that, we had to design checklists which were usable or suitable for the site. Then we had to do space coding because it was a very large site. Then we had to see the current status of fire alarm and extinguishing systems in the site, and then we identified all potential fire outbreak locations and ignition sources, and also we assessed the materials and their vulnerability to fire extinguishing systems that we were going to use later. And at the same time, we did a qualitative evaluation of structural stability. In case something happens during this year, we were sure what would happen to that. This is a sample of the checklist that, well, it is in Farsi language, but if I explain here, we had, this checklist is just for one space, I would say for one shop, for example. which explains about the material type, the type of structure, the openings, the type of the material of the windows, so on, and also the type of shop, what it is sold there, and so on. And also we had to do a space coding for the whole, and we had to check and get the information from every specific part. As you can see here, the number of shops were over 400. The bazaars around were 20 parts. The ceilings around 1,000. The closed spaces more than 200. The roofs more than 200. Balconies on the second floor were over 300, and the walls in shops were 1,600, and the walls in the three historical buildings around 1,000. The area surveyed was more than 55,000 meters square, and the time we spent there was over 7,000 person hour. First, we went to fire risk assessment. To do that, we had to choose a method which was usable. We chose the ABC method, which is suggested by ICROM for the museum, but somehow we developed the method in order to be applicable to the site and to the buildings. And at the end, we were able to sort the magnitude of risk. Again, here you can see, but here you see the building, the space, and the item. It means that maybe there were more than 2,000 or 3,000 of these items, and we were able to evaluate the magnitude of risk and then give priority to them to tackle. Then we had to develop the intervention plan, and for this reason, well, I just explained some parts that we did. First, we had to study and suggest a plan to reach the different parts of the site by fighters. Then we suggested water reserve sources in different parts. In order something happens, we need water. Therefore, we suggested in which part they should be. Then the communication system with the fire station around was not so good. We did some design for that, and also most of the shops or even the buildings were not insured, and we planned them to get fire insurance in case of any incident. Then we went to compartmentation of different parts in order to prevent the fire from progress. If something happens, we just went for that. And also because it has two sides. One side is the historical buildings. Inside, we had to have a counting system to know in real time how many people are there in order to be able to evacuate, and also people who are in bazaar. And then for each specific space, we suggested the fire alarm system. For example, here we suggested flame detection camera, the fire extinguishing system, for example, and also other actions that should be taken. For every single one, we did it with the help of experts. And also for the maintenance of the system, which was going to be installed later, we did some plan, and also for alternative communication system in case of power and telephone outage, we did some plans. And also because there are some items which are like a wooden door or some drawings and so on. We made catalogs for each and made the priority in order if something happens, the fire brigade knew where the item is located and what he or she should do. And also we, in order to mitigate and to prevent somehow, we suggested some precautions in order to protect during the fire. And also for action during an incident, we planned for quickly alerting the fire station. Also, we prepared guidelines in order to be installed every part, and also the guideline for the evacuation of the visitors to be installed in every part. And also we did some plan for emergency response in different parts that everybody knew what is he or his duty. And for each building, we prepared a booklet called Fire Extinguishing Plan and Guideline. For example, for the bazaar around, it included the fire extinguishing plan and guidelines. Then we prepared the site plan for each part of that. We prepared plans for evacuation routes and also the evacuation procedure for the visitors, and also for the security personnel who are there for fire. And also we did some other guidelines for people who go there, and also we prepared an SOP for every part of the bazaar. And this is one of the catalogs that we prepared for the rescue of historical parts. Here it is a historical wooden door. I thank you very much, and hope you have enjoyed that.
Thank you, Professor. Thank you very much for your very interesting presentation. Now we can go on with the last speaker, with Andreas Galmarini, a structural engineer with a background in bridges and reinforced concrete structures. His portfolio contains projects all around the world. He is a member of the Swiss Humanitarian Aid Unit with focus on structural assessment after earthquakes, and since 2016 he is a member of the board of Walter Galmarini, a structural design office in Zurich, working on hybrid and mixed material bearing structures. Today we'll speak about the reconstruction of one of the most important heritage buildings in Bhutan and that fell victim of a fire. Professor Dr. Galmarini, thank you. The floor is yours. We can see your screen.
Very good. Thank you. I hope you can also hear me.
Yeah.
It's a pleasure to present this case. I'm presenting the case overall, giving an introduction, speaking about the reconstruction, and then the fire protection measures implemented. We are in Bhutan, so the Bhutan is this very small red dot between India and China. It is has an altitude in this area of around 4,000 meters, or 3,000 to 4,000 meters. And within the country, we are at the intersection of the east-west and north-south axes. Here you can see the two rivers coming together, and on this hill is the site of this dzong. In Bhutan, they have the speciality that in every region they have the administration and the religion gathered in power centers, and these are the dzongs. Our dzong that we are looking at has over time not changed a lot. In the 60s, you see on the right side, the image, it's really on the hill, accessible especially from the back of the image. It was built in the 17th century of the state founder. It was the second capital of Bhutan. And we know that there were major works after the fire in 1837 and about 50 years later after an earthquake. If we look at the the Dzong, how it is built, it is about 200 meters long, 50 meters wide. It contains courtyards surrounded by shop cores. These buildings you see on the left side. And then there are towers which host the more important temples in every courtyard. And the most significant of those is the Utse in the third courtyard, the higher one here. If we speak about the structure, then we also have to speak about what the materials are used. It is a lot of stone. There is also some rammed earth traditionally. Then there is a lot of timber. Timber is used for the roofing, for the flooring. There are mostly built up members that are intricately painted and carved. And on the right side, you see the masonry. Between old and younger, you see a lot of variations. Now coming back, this is the Dzong in its beauty in 2012 spring. Unfortunately, on the 24th of June, something happened that is very similar to what happened today in Copenhagen. The day after, it looked like this. It was burned totally. And why has that happened? Actually, the source of the fire, an electric short circuit, happened in a very good location, supposedly just beside the entrance. Unfortunately, the first thing that happened is that the entrance tower collapsed and that the people could not enter, and state television showed the entire night how the national monument, which is also on the tentative list for the World Cultural Heritage, burned down. The sources is very similar as discussed for Mongolia, the electric installation and the butter lamps. Another source for endangering those structures is the earthquake, and there has been recent earthquakes giving always the same type of damage. With having this structure burned to the ground, the question to the local people, local administration was what to do. Shall we do something modern with the modern standards? Do we rather want something very traditional? If we want it traditional, shall it be very conservative minded, so making exactly the same again, or as the clergy would like, a very splendid traditional design? To solve such questions, the Bhutanese have a very standard system. They call in international experts and make a workshop, which happened here in this case in 2015, with some participants of this colloquium also participating. We then got the job to help the locals implement what we found out. The main goal actually was the earthquake proofing. And here we saw these delaminating walls. We mitigated that in inventing a Fritz stone element, trying to stick together the left and the right side of the wall. As you can see, we did a little prefabrication yard and then an implementation. This is the sample wall to assure that it was not giving a negative impact in the heritage value of those walls that had to be rebuilt completely because the stones were cracked due to the fire. We then tied together the entire buildings by a ladder beam connecting to the flooring. You see again the system laid out. It's of course resembling to the Fritz stones, just interconnected in a very soft way in order not to disturb the properties of the stone masonry with mud mortar walls. Then the flooring, we had to make them more stiff in plane. So instead of having one layer of timber planks, we had introduced 2 layers which were nailed together under 45 degrees. With that, we could earthquake enhance 90% of the structure, but there was still the highest tower that in the original had a very high basement, which was basically only structure and a stair, and it should host more temples and be higher for the clergy. And it was very narrow, or is very narrow on one side. You saw the hill is very steep, so no chance we could increase the width of that structure. So what we did is we implemented a base isolation with walls up to 1.8 meter thick. The weight is a real issue, so we had to combine not only the elastomeric bearings, but also use sliding bearings to cope with the weight. A big issue was the look of such a modern intervention in a traditional building. It was decided, though, that it could be implemented, and with that we had the basic design solution to the original. So this was the design. We were working there over half a year to get the basic of design ready. And within that time, we also said, well, it's a little bit funny to look only at the earthquake proving. Why shouldn't we also try to implement at least some measures to address fire safety? And we got some help from a friend of mine from the building insurance company of Zurich. We tried to address reducing the source risk, reducing the speed of spread, and improving the firefighting and people's safety. What did we do? One is, of course, trying to improve on the electrical wiring. You see in the middle a picture that is significantly better than what has been there, been in place before. But on the right side, we also see that when you start on a very low level, then you can reach so far, but there will always be some glitches. Similar to the open bottle lamp discussion, we had it in Mongolia. It is very much the same here. The measures are the same, and the conclusion that you cannot prevent them from occurring is also the same. Fire spread, we try to really make the compartmentalization, these brown areas, which was of course helped by having quite thick walls in the first place. So what we try to do is there where we had timber walls and timber elements, to have those at least strong enough to provide some duration. Having fire cuts here, we also have, we failed in a way. One of the very classical items of Bhutanese architectures is the flying roofs, and they were overlapping or are still overlapping, and we tried many different ways, but the locals, they said they cannot change from having these flying roofs, so we guess they will still be one of the major drivers of the spread of the fire. There were no hydrants before. We did improve in a way that we introduced hydrants both inside and outside in the different courtyards. As you can see, the courtyards can be very narrow, so it is a question not only of having fire hydrants, but also how to get to the area of fire. Then we suggested not training only external people for the firefighting, but rather use the monks that live here and are here permanently. They can spare some time and train firefighting. Then of course reduce the time or the equipment. We introduced a tunnel below the whole historic structure, collecting all the piping, which is good not only for the firefighting, but also for the structure itself, because having water seepage rather in the tunnel than in the mud walls is an advantage. You see some image of all kinds of equipment for firefighting dispersed throughout the structure, and some alarm device which should help reduce the time firefighting. Of course, water hydrants are only useful if you have water, and in this place this was not even too easy. We had to collect it quite far and build tanks of various sizes and shapes in order to have a reasonable amount of water once it should occur. Then I mentioned it before, safe access for the firefighter is important, as we saw with the cause of the fire. But also evacuation is an issue, and we introduced at least one safe exit or two in every courtyard. Note that this first big courtyard is used for festivals every year and is very, very crowded during that time. Then also we introduced a pathway around the structure so that people could not only go and then tumble down the steep slope, but really can walk around the slope. In the below picture, the dashed line is the tunnel. We started in 2015. End of 2022, the structure was inaugurated. I think the conclusion we took is if you have an old structure and you need to reconstruct it because it was damaged by either the fire or the earthquake, you can have basically three approaches. One is to use the traditional techniques and the traditional structure. If you do exactly the same, the outcome will be likely all the same again. Or you can go to the other extreme and abandon the traditional structure and say that's not safe. We want to do something modern, which, as you can see, has some issues with the heritage value. Or what we tried, a middle way, is to use the traditional techniques and improve it with modern elements. You cannot avoid that you see them, but you see them in a very reduced manner. To show this, before finishing, some pictures before and after. Left above is before, and the refurbished or reconstructed structure down right. Again, the narrow courtyards, you see there we kept the basic features, the very narrow spaces, the stairs, and so on. Then here, this Utse Tower with the horizontal line being the space, the movement space of the tower. And with that, I would like to come to a conclusion and say that, of course, I have presented this project, but there's many people who have contributed in a significant way between 2015 and 22. So that is the initial picture again, before and after. And with that, I thank you for your attention.
Thank you so much. Thank you, Andreas, all the speakers for the very nice presentations. And I think that we can open the discussion. Maybe we have the first question. Is Tim there, or can I start?
Yes, so to all the participants, please put your questions in the chat, and then Nicoletta and I will feed them to the presenters. I would like to touch on like this topic that we've seen from all the presenters, and that is this theme that we see coming back where low-tech risk prevention measures are essential, but that we also need some state-of-the-art sometimes systems such as fire alarms. I think Paulo Lorenzo, our ISCARSAH president, asked like, why was there no camera system and why was visual confirmation required at Notre Dame? And so I would like the presenters to ponder this question for a moment. Like, how do you work around this trade-off between very basic measures? Andreas or Mehrdad, if any of you want to go first. Chris,
sure. It's a great question, Tim. And I think, there's so many variables that go into this, and it would be great, like in Mongolia, I mean, from a financial perspective, having the resources to be able to do that was somewhat limiting there. And then also just, looking at, contractors in terms of just installation and are they close by and testing and maintenance and so forth. But some of those, factors were factoring into what we were doing. There was really nobody around for the installation or the ongoing testing and maintenance. And ideally, yes, it'd be great to have sprinklers and fire alarm, but it just, again, would they be working and operational? I have heard some different things in terms of Notre Dame, that one of the thoughts on the fire strategy was that it was oak wood that was very hard, that they some of the assumptions early on were that it was not going to burn quickly, which was not really a correct assumption. But then that would give them time to go up and investigate, having that smoke detection system in place, and therefore they could then, get eyes on it and then relay that back to the fire department. I don't know much more than that, but I think, going back to, Professor Torero and just, some of these things, I think now we have a lot more in terms of the tools and the technology and better understanding of the fire and mitigation measures, to continue to help to make more informed decisions in terms of what may happen, with the fire growth, but also the impact of these mitigation measures, and allowing stakeholders to make decisions, for various reasons and what objectives they're trying to achieve through having this information. But I think, I don't know if that helps at all, but I think, there's definitely opportunities.
Great. Andreas and Mehrdad, any comments on that, or shall we move on to the next question?
Well, in my
Andreas, go ahead.
In my case, it's almost a lawless or regulationless area. So even introducing the basic concepts, I think, was a big step forward. And of course, it would be nice to have sprinklers and high-tech equipment. But on the other hand, we had to weigh, is it better to have a high-tech equipment in the first 5 years and with a high probability of nothing working anymore? Or do we focus on maybe not the optimal solution that we could imagine in a place like Notre Dame, but rather just to see where can we go?
It is forbidden to use open flame. It means that if there's a candle, nowadays it is not possible to use that. Instead, they use some lamps which work with battery, and they resemble the candle. Well, probably it works to protect fire, but for ritual manners, many people don't like it.
Thank you, Mehrdad. Everyone, please, if you have further questions, put them in the chat. Nicoletta, do you want to take the next one?
Yeah, basically, we would like to stay under this discussion. From Carly Connor, it comes this question. Basically, is it possible to integrate fire protection measures that would also potentially allow buildings to be insured and have affordable premiums? So, also, is it possible to allow select changes building to show the long-term preservation benefit? I think he wants to have examples of key fire protection measures from you.
Or Andreas or Mehrdad, I think one of the interesting other elements raised in this question is how this all interferes or relates to insurance policies, right? So at least in the US, I feel that insurance is a big driver in how we deal with some of these risks. And so I am curious where you work. Andreas, you mentioned that you got some support from a insurance company to do the work in Bhutan. When you do work in Switzerland, for example, is that work driven by requirements to get affordable premiums, or is this more work driven by the desire of property owners, or both?
Well, in Switzerland, the approach is combined. There is regulative requirements. So even for the building permit, you have to, note some kind of safety installations, and the building insurance company itself will of course force you to have some measures done. The case of Bhutan, it was a mere coincidence that this guy is a personal friend of mine and helped us. So it has nothing to do with there. The context is very different. And I think it's also an interesting one because the population is extremely religious compared to Europe. So one of the ministers, even so top level government, he told me, Andreas, this is very nice what you do, but I must tell you one thing. Earthquakes and fires, they happen because the gods want to punish us. So what you're doing is basically only making it more difficult for the gods to punish us. And they will just increase the size of the magnitude of the earthquake or the size of the fire. And that really is a very difficult argument, which I didn't find a very conclusive, bulletproof answer to. So it was in that context, I thought we did a good job in getting somewhere, but you fight a bit the windmills, no?
Yeah, of course. Sure. I think Kaushal Patel, sorry if I mispronounced that name, has a very important question. And he mentions that to install all these fire protective measures, we often need to intervene in historic buildings, which requires additional pipes, wires, running elements through potentially valuable contributing fabric of the buildings. And so how do you balance this question of fire safety and then appearance and values of a building? I'm sure both Mehrdad and Andreas, you've had to deal with that question. It's also something that in general ISCARSAH guidelines, I think, can help with, but I wonder if you have specific comments to that.
Yeah, well, it depends how much intervention you need for the job that we did for the Maidan. The intervention was not so much. It means that with a small instrument and choosing compatible colors, which is not distinguishable from distance, we were able to design, and at the same time we had two groups, one group of experts in fire and one group experts in cultural heritage. Then the fire department or us, if we were on that part, we suggested some devices, and then if it was not approved by the cultural heritage sector, then we went for the alternative. In our case, we didn't encounter a big problem, but my opinion is, if we are for a decision between the safety and containing the some, I would say, values, then we should discuss it. If sometimes we need to do some intervention in order to save the whole building, otherwise in an instant we would miss everything. Thank you.
Thank you, Mehrdad. That's great further insight. We also have a question from Yuekian Wang about the usefulness and the importance of digital recording, whether that's 3D scanning or other types of documentation, and if they can help in decision-making in fire risk management of heritage architecture, or I think maybe the way it might make an important contribution is in, unfortunately, reconstruction. I don't know, Andreas, if you can comment on that, because it seemed that you must have had a certain level of documentation available to recreate the monastery in Bhutan.
Yeah, we were, how to speak, fortunate maybe that just in the spring before the fire, they had an archaeological survey of the whole building because they were refurbishing it gently, let's say. So there was some documentation. And in Bhutan, there is the particularity that they still know the traditional ways of building. So there are still head masons and head carpenters that know the techniques. So there is a blend of the old overall structure and the new wishes of all the new inhabitants that got together for the new design or the reconstruction.
Thank you. Mehrdad, is documentation an essential part of the management plan in Isfahan?
I think, yes. Actually, I would say that we have a big project for the square in order to make 3D laser scanning and also photogrammetry. In case something happens, such as earthquake or flood or even fire, it makes it possible. If something is missing after the incident, then we are able to somehow restore or reconstruct or something like that. I think it is very important, especially for next generation. Say, maybe in 50 years from now, if there's an accident, at that time they will know what was the situation. I would say documentation every, say, 10 years is very important.
Thank you. Go ahead, Nicoletta.
Yeah, I was checking if there were other questions from the crowd. In the meantime, I wanted to ask a personal question, because it seems that there is a recurrence of fire events during renovation and retrofitting works that make the structure, of course, more vulnerable and exposed. How do you think it will be better managed and prevented, and how municipalities and government are responding to this? I don't know, maybe Andreas can give us some examples.
Maybe I pass that one on.
And also, Jose and Chris had to leave, so maybe we will pose them this question.
It is, of course, we cannot get around it that you see the scaffolding around Notre Dame Cathedral during the fire. You see the scaffolds in Copenhagen today. So there's definitely increased risks, which I would assume would need to come with increased management plans of that risk. I'm curious, we're running this webinar, and Steve Kelly has been working behind the scenes and has been working in fires in the US very much. And I wonder, Steve, or maybe our president, Paulo Lorenzo, if you can give some thoughts on the question that Nicoletta just posed about how renovation can actually maybe increase fire risk and how we should deal with that.
I mean, also, if I can make a comment, also in the Dzong in Bhutan, they were doing renovation works, to my understanding. And so obviously, as you bring people in, it's not only an issue of bringing combustible materials and accumulating these materials in a location, but often people misbehaving, namely smoking on site. And so I think this is considered, and it is evident that you increase the risk while you're doing these works, no?
Mhm.
In our case, in the United States, we see an awful lot of fires that are started by people that are installing roofs, because roofing is often put down using flame torches, and the roofers are not, they're not really very well trained to control those fires. Normally they go up on a roof and they take fire suppression equipment with them, but they can very easily burn a hole through the roof, start a fire in the attic below, and they don't know that it's happening until it's too late. So we see that an awful lot of, especially with churches and places of worship, that roofers start fires and they burn buildings down.
Thank you for those insights. Andreas?
If I take the question to Wang Dizong, it is true that there has been renovation works going on, but the fire was already after the renovation works, and it was unrelated in that case. If we take the case of a railway, working along a railway line, then there is a separate person looking only after the railway traffic while the workers are working. And I think if we really want to, or in many cases, if we really want to do something about it, that would probably be a way to go, to assign somebody that is responsible only and specifically for the fire risk, and not combining, putting that duty also on workers that really focus on other things.
Thank you, Andreas. I think that's an important comment. And I think in general, fire risk should be something that's at the forefront of management plans of historic buildings, and when dealing with renovations or just operating these buildings. And I think that's a good note to end on. We will unfortunately keep getting these reminders by seeing these horrendous disasters like this morning when things burn down. But I think it's essential that we keep communicating strategies to prevent these fires and to fight them. So with that, I would like to thank our speakers for joining us today and all questions and participation.